Next, I have this piece of code. I have to analyze and find the time complexity of this one. And this code also for loop is used. But loop is starting from 1 going up to n, that is less than n. And it is being multiplied by 2. I is multiplied by 2 every time. So blindly we cannot say this will execute for n times. We have to analyze this one. Let us see how many times this will execute. It's not n. We don't know how many times. Let us see. I will take the I value. Initially it is 1. The next time is going to be 1 into 2, that is 2. The next time it will be 2 into 2 again, so it will be 2 square. See, every time it's getting multiplied by 2. Then it's 2 square into 2 again, so this will be 2 power 3. Goes on. How many times? That we don't know. So let us say this will execute for 2 power k times. 2 power k times. Now, we know that this will terminate when I becomes greater than or equal to n. So we assume that when it has reached for some k number of times it has repeated, assume I became greater than or equal to n. And what is our I value? 2 power k. Since I is equals to 2 power k, therefore 2 power k has become greater than or equal to n. Now if I take 2 power k is equals to n, then k is how much? Log n base 2. Yes, this is the time complexity. So the statement will execute for order of log n base 2 times. So from this we can observe that if you have a loop where the counter variable is not incrementing but it's getting multiplied by something, let us say 2 or 3, then it will get log base 2 time. So it will execute for log base 2 times. Now I have a incremental for loop here, the regular loop that we use. Let us analyze that one and then we will analyze once again here the other method I will show you. See here, I is initially 1 and it is incrementing by 1, plus 1, then plus 1, then plus 1, goes on plus 1, and it will stop when finally it becomes greater than n, so up to n. So how many times it's getting added? So let us say k times, and that is equal to n. So how many times? K times. What is that k? It's equal to n. Now let's take this one. I is initially 1, then it is next time into 2, then again into 2, then again into 2, so up to some times. So finally it will stop when it becomes greater than or equal to n. Then this is how many times? So this will be, let us say, k times. So what will be the result? This will be 2 power k. That will be equal to n. So k is how much? Log n base 2. So the other way I have analyzed this one. So that is incrementing 1, 1, 1. So k times. So this is multiplying by 2, 2, 2 every time. So k times it's getting multiplied. So it's 2 per k, that is equal to n. So k is how many times? K is log n base 2 times. So if you have any loop like this, the value of I is getting multiplied, then it is going to take log n time. So you can take it as a formula now. The time complexity taken by this algorithm is log n. The statement will repeat for log n times. Now when you take log n may give decimal values, float values. So we need to know whether I have to take floor or seal of that value. So that is important. Means shall we truncate it or round up the value? So for that, let us take some example and check it. Suppose n value is 8. Right? Now I value, let us trace this one by taking a sample value. I is 1 initially, then I is multiplied by 2, so it is 2, 2 is less than 8, 2 is less than 8, then again multiplied by 2, 4, so 4 is less than 8, n is 8, right? So again multiplied by 2, now 8 is not less than 8, so it will stop. So total how many times it is repeating? It is repeating for 3 times. The next, if I take the n value as 10, If I write the n value as 10, let us see what happens. I is initially 1. 1 is less than 10. Now n value is 10. 1 is less than 10. Continue. It's multiplied by 2. So 2 is less than 10. 4. 4 is less than 10. 8 multiplied by 2. It is 8. 8 is also less than 10. Then 16. So 16 is I. I is not less than 10. So it will stop here. So total how many times? 4 times. It's executing for 4 times. If I find log 8 will be 3. How? Log 8 is written as 2 power 3 base 2 and it is written as 3 log 2 base 2 and this is 1. So answer is 3. Now same way, if I find out log 10 base 2, now 10 is not in exact powers of 2, so I may not get the decimal value, integer value, I may get a decimal value, right? So let us take it as example 3.2. I am assuming it as 3.2. I got 3.2, but if you see the number of times repeated, 4 times. So it should be taken as ceil value. So this log should be taken as ceil. When you use log sometimes, whether it is ceil or floor, that is also important. Right. Another piece of code here, let us see how it's going to execute, what will be the time complexity of this one. See here, I is starting from n. The next time I value is n by 2. The next time it's n by 2 square. Then n by 2 cube. So on. How many times? N by 2 power k. We don't know the number of times, so we are assuming it as for k times. And we know that the loop will terminate when I becomes less than 1. So it will continue as long as it's greater than or equal to 1. So assume I has became less than 1. So therefore, what is I value? 2 power k is less than 1. So if I equate it, then it's going to be 1 and n is equals to 2 power k. So k is how much? Log n base 2. So again, the time for this one is order of log n base 2. So the time complexity of this piece of code is also log n base 2. So the previous one, in the 5th example, I have shown you that it was multiplying every time and starting from 1. Now this is dividing every time, it's starting from n. And up to what? Up to 1 it is reaching. So it's order of log n. Next piece of code is the 7th example I am taking here. So here I is starting from 0 and I into I is less than equal to n. So how many times this will execute? This will execute as long as I into I is less than n. But it will terminate when I into I is greater than equal to n. We assume that I into I is I square is equal to n. So what is I? It's root n. So I don't have to k here, I have not used k here, directly using I only have shown you. I into I is less than n min, this is a square, if you send that side it's a root, so it will execute for root n times. Now the next example, here I have 2 for loops, these are independent loops one after another. Don't mistake it as a nested loop, they are not one inside another. So the time complexity for this one is, this is independent loop and it is iterating for n times and it's incremental loop, so it's order of n. And this is also an incremental loop, this is also order of n. So if you combine them and take their time, that is 2 plus 2, sorry, n plus n, that is 2n, and it is order of n. So this is an independent loop and the time is order of n only, n plus n, that is order of n. It's not n square. Now next one, I have 2 loops here, independent loops. This next loop, I have to find out what is the time taken by this statement. If I observe only this one, then j is taking values from 1, j is less than n, j is incrementing, that is updating by multiplied by 2 every time. So this is going to take log value. Log of what? Log of p. So this is log p. What is a p? If you see the previous loop, here p is incremented. So p is incremented in this loop, so this p will take the value that number of times this loop is repeating. How many times this loop is repeating? I take the values 1, 1, 2, n, and I assign I into 2. So again it is log. Log of what? It is log n. So p value will be log n. And this statement will repeat for log p times. So what is p? P is evaluated here and it is used here. Right? So this is log of log n. As p is equal to log n, so it is log of log n. So the time complexity is order of log n. Next example, here I have nested for loop. The outer loop is taking I assign 0, I is less than n, and I is incrementing. So this is order of n, as this is the increment loop, so this is order of n. And whatever is there inside will repeat for n times. Next, the inner for loop, this is using j is less than n, and j is every time multiplied by 2, right? So this will take log n time. So this itself will take log n time, and anything inside that also will take log n time. If you remember, initially I have shown you that this takes n plus 1. No, it will not be any useful if we write n plus 1 or don't write it. It makes no difference. Just you can take it as n. Now total how much? 2n log n plus n. So highest term is this one. So this is order of n log n. So the time complexity of this one is order of n log n. Now let us write some pieces of code and see what the time complexities that we have got so far. See, if I write a for loop for I assign 0, I is less than n, I plus plus. For this we got the time as order of n. This is the incrementing loop. If this is written as I assign 0, I is less than n, and I assign I plus 2, this is going to be n by 2, that also we take order of n. Then for I assign n, I is greater than 1, I minus minus, this also order of n. So if it is incrementing also order of n, if it is decrementing also order of n. Then for I assign 1, I less than n, I assign I multiplied by 2, this is order of log n base 2. So it means for I assign 1, I is less than n, I assign I into 3, this will be order of log n base 3. For I assign n, I is greater than 1, and I assign I by 2, it's order of log n base 2. So now we can take these as formulas. If a loop is incrementing, then is n, or decrementing, it is n. Whether it is incrementing by 1 or 2 or even 10 or even 100 also, it's order of n only we say. Right? N by 2 is also order of n. N by 200 is also order of n. Because we are writing the degree of the polynomial, that is n is the term used there, the variable n is used, so it's order of n. If it's n square by 2, then we say n square. Right? So this is a summary of the time complexity we have seen.